Alright, today's lesson is how to factor polynomials. And there's a couple of different ways that we can factor. It's very similar to factoring with quadratics. And here are the ways we can factor. You can take out a GCF, just like with quadratics. If it's a quadratic, we're going to factor the same way that we did before. So when a is 1, we can use the shortcut. When a is not equal to 1, we have to do the longer way. Difference of squares, when we can take the square root of both terms, and then one is plus and one's minus. When you have 4 terms, you're going to use grouping. And then there's cubic special cases. So there's difference of perfect cubes, and there's sum of perfect cubes. The GCF, if we want to factor out the greatest common factor, we're going to do the same thing we do with quadratics. So the first thing you always want to look for is a GCF. So in this first example, x cubed minus 5x squared minus 6x, they all have what in common? An x. If I take the x out, I'm left with x squared minus 5x minus 6. What we're left with now is a quadratic that has an a value of 1, so we can factor this further. So the point of this is to factor all the way as far as you can go. So if you factor one way, you might still be able to factor another way. So we took out the GCF, and then we're going to factor. So multiplies to negative 6, adds to negative 5. We're going to use negative 6 and positive 1. And the second example, same thing, take out the GCF. So we're going to take out the x, and we're left with x squared minus 2x minus 15. Again, we have a quadratic, so multiplies to negative 15 and adds to negative 2. So the x will stay on the outside, and I'm going to use negative 5 and positive 3. And that's as far as we can go. Yes, we're not solving any of these right now, we're just factoring. And the last one, we're going to, again, take out the GCF, which is an x. We're left with 2x squared minus 7x plus 3. Again, we have a quadratic, but in this case, my a value is not 1. So I have to do a times c. So multiplies to 6, adds to negative 7. So we can use negative 6 and negative 1. Since this is the longer way, since a is not 1, we have to bring down the first term, bring down the last term, and rewrite the middle term using the two factors that we got. So minus 6x minus 1x. And we're going to ignore that x on the outside for right now. So this x, we're going to come back to in a minute. So we're just going to use what we have here. We're going to group it. We're going to take the GCF out from 2x squared minus 6x. So that's going to give me a 2x, and I'm left with x minus 3. The negative x plus 3 has a negative 1 in common. I'm left with x minus 3. So the two parentheses should be the same, which they are. They're both x minus 3's. So we're going to take the two outside terms and put them together. 2x minus 1. And then the x minus 3, we write it once. And then the x that we took out in the beginning, we're going to put back in front. So we have x times 2x minus 1 times x minus 3. Now we have one that's called factoring like a quadratic. So whenever you have your exponents that are 4, then 2, and then nothing, like this example, you're going to treat it like a quadratic. So if we look at the first example, I have x to the 4th minus 3x squared minus 4. So if we just think about this as a quadratic for a minute, if we had x squared minus 3x minus 4, how would we factor that? Okay, so multiplies to negative 4, adds to negative 3, so this would be x minus 4 and x plus 1. So we're going to do the same exact thing, except now my first terms in each, instead of being x, are going to be x squared. So this going to be x squared minus 4 and x squared plus 1. If you FOIL it back, you can double check, and when you FOIL it, you'll end up with x to the 4th minus 3x squared minus 4. And if we look at this, we can still go one step further. And this x squared minus 4 is difference of squares. So you need to be able to recognize what type of factoring you need to do. So completely factored, x squared minus 4 is going to be x plus 2 and x minus 2. And then the x squared plus 1 I can't break down, so I'm going to leave that. And that is completely factored. Okay, so if we look at the next one, x to the 4th minus 10x squared plus 9. Again, pretend that it's quadratic. So what multiplies to 9 and adds to negative 10. So I can use negative 9 and negative 1. The only difference here is that I'm going to use x squared instead of x. So I'm using negative 9 and negative 1. Now if we look at these, both of these are difference of squares. I can take the square root of each. So x squared minus 9 becomes x plus 3x minus 3. And x squared minus 1 becomes x plus 1, x minus 1. And there we are, fully factored. Okay, and similarly, in the next one, okay, we're going to, again, factor as if it were a quadratic. So multiplies to negative 12, adds to 4. So we're going to use x squared, and we're going to use 6x, no, just 6, sorry, and then x squared minus 2. And since I can't take the square root of 2, I'm not going to break that one down at all. It's not difference of squares, so I just leave it the way that it is. Okay, some more examples of the same type of thing. Well, if we look at this first one, we always want to look for a GCF first. So the first thing I can do is I can take out a 3. Then I'm left with x to the 4th minus 7x squared plus 6. And then from there, the inside is now treat it like a quadratic. So multiplies to 6 and adds to negative 7. So I'm going to keep the 3 on the outside. And I'm going to use negative 6 and negative 1. And if we look at that, difference of squares, I can't do difference of squares with x squared minus 6, since 6 is not a perfect square. But I can do it with x squared minus 1. So I'm going to keep the 3. X squared minus 6 stays the same. And this becomes x plus 1 and x minus 1. Okay. Grouping is when you have 4 terms. If you have 4 terms, you want to group. If you group the first 2 and the second 2, this is similar to how we factor quadratics the long way. You have to have the same expression within the parentheses. So there's 4 terms, so I'm going to group it. I'm going to take out the GCF from the first 2. So I have x cubed plus 4x squared. So I'm going to take out an x squared, and then I'm left with an x plus 4. The 2x plus 8, I'm going to take out the common factor, which is 2, and then I'm left with x plus 4. So these should be the same, which they are. So we're going to smush the 2 outsides together, x squared plus 2, and then x plus 4. And nothing else can factor, so we're going to leave it just like that. Okay, if we look at the last one, we're going to do the same thing. So we're going to group the first 2 and group the second 2. Take out the common factor, so x squared, and I'm left with x plus 3. Negative 4x minus 12, I'm going to take out a negative 4. I'm left with x plus 3. So again, these 2 are the same, so we're going to smush the outside terms and keep the x plus 3. But now, the x squared minus 4 is difference of squares. So x plus 2, x minus 2, and then x plus 3. The last type of factoring we're going to look at is the sum and difference of cubes. So this only works kind of like the difference of squares, where you have two terms only. In this case, they both have to be perfect cubes. So if you take the cubed root of each, you're using those values. So this is something where you have to memorize what it is. If it starts off as a difference, where you have a minus sign here, the first sign is going to be minus, then plus, and then the last one will always be plus. If you start with a plus, you have a plus, then a minus, then a plus. So the last one is always a plus. Then the other two depend on which one it starts with, and then the other one is the opposite. So if it starts with a minus, you're going to have a minus and then a plus. If it's a plus, you're going to have a plus and then a minus. So for each one, what we're trying to do is take the cubed root of each. So if I take x cubed, the cubed root of x cubed is x. So I'm going to rewrite that as x cubed. And 27 is the same thing as 3 cubed. So the x and the 3 are going to be like our a and our b in here. So I'm using the sum of cubes since it's x cubed plus 27. So I'm going to plug in a plus b. So that's going to be x plus 3. And then I had the a squared, which is my x. So x squared minus the x times the 3, so 3x, plus b squared, so plus 9. That's my 3 squared. And then I'm done. So these are never going to be able to be factored further. Whatever you get, you're always going to have some binomial plus an additional quadratic. So you're going to have the x plus 3, and then in addition to that, you have x squared minus 3x plus 9. Now that quadratic will never be able to be factored, so you're just going to leave it. Okay, so if we look at the next one, this is like x cubed, and then 5 cubed. So x and 5 are the values I'm using. So it's a difference of cubes. So I'm going to do x minus 5. And then I'm going to have x squared plus 5x plus 25. So it was the first one minus the second one. And then the first one squared plus the two multiplied together plus the second one squared. Okay, and let's look at the last one. So x cubed. And this is the same thing as saying 10 cubed. So again, it's sum of cubes, so x plus 10. And then we're going to do x squared minus 10x plus 10 squared, which is 100.